name is Sophia. Today I will show you a quick demo to show how you can use Projexlight to generate code and then run it using the CLA tool. First, sign up with OAuth. If you want to use a personal email address, choose the personal sign-in option. If you prefer a company email, use the standard sign-up screen. Once you complete OAuth, you will be signed in automatically. After signing in, you will see a starting balance of $10 in credits. This free credit is used to pay for initial LLM calls on the platform. You get a limited number of free LLM calls, and after that you will need to use your own LLM key for further generation. Because of that, it is recommended to set up your own LLM key early. If you just want to experiment quickly, you can select a low-cost model like GPT-4 Mini from OpenAI. Otherwise, you can configure your own preferred provider. Go to the LLM settings, click the button to select a provider, choose a default model, paste in your API key, and run the test to confirm that the model is working correctly. Once the test passes, you are ready to use that model in your projects. Next, configure your cloud provider. If you have AWS, Azure, or Google Cloud, you can connect it here. For this demo, an AWS account is already set up. Select your cloud provider from the drop-down, then fill in the required information, including at least one S3 bucket or equivalent storage bucket. This storage is used to persist generated files and artifacts from your projects. After cloud setup, define your coding standards. Go to the coding standards section and upload your guidelines. You can browse and import a markdown file or other supported formats with your rules. For example, you might include naming conventions, architecture patterns, or code quality rules. Once imported, you will see your list of coding standard rules in the interface. These standards will later be used during code review and validation. If you want to collaborate with others, you can invite teammates as employees in your organization. Go to Roles and AMP, Access, then to the Employee tab. Select your organization and click Add Employee. Enter the person's email address so they receive an invitation link. When they sign up with that link, an account is created for them, and they are logically attached to your organization. At the same time, they still have their own personal organization, where they can create projects that you cannot see unless invited. Your collaborator can switch between their personal organization and your organization using the organization switcher. In their own organization, they can create private projects. In your organization, you can add them to specific project teams and assign roles and permissions. Until you explicitly add them to a project team, they will not be able to access that project. Once added, their permissions will control what they can view or change. Next, go to Billing. Here you can enter your billing information and review usage. You can see daily usage, cost trends, and other billing details. Once this basic setup is complete, you are ready to create a project. Go to the Projects tab to create a new project. You can use the New Project button on the dashboard or within the project screen. For example, create a project called Writer App and enter a brief description of what the project does. After saving, the project is created and you will see a prompt to start refinement. Refinement is the process where you clarify and structure the project requirements. Click the Refinement wizard. In the wizard, you first select the LLM providers available for this project. The providers you see are based on the keys you have configured in the settings. Projexlight supports many providers, but only the ones you configure will appear as options for this project. Each provider may expose multiple models. For this example, choose GPT-4 Mini because it is cost-effective for iterative refinement. Now describe your project. If you are creating a project from an existing application, like an e-commerce platform, you can also provide real data. For example, if you have performance issues or low conversion rates, you can export analytics data from your database, Google Analytics, or other tools in CSV, JSON, or Excel format. That data can be used to analyze where problems are happening and to shape better requirements. If you are starting a brand new project with a new idea, you can simply write a short description. 10 to 15 words is enough, though you can provide more detail if you like. Click the button to generate the initial refinement. The system will propose structure, goals, and questions based on your description. Review the generated content and the list of questions. As a product manager, this step is important. Answer the questions as completely as you can, using whatever information you already know about the project. Then accept the refinement and continue through the remaining steps until the refinement flow is complete. In this demo, a project has already been refined fully. Open the existing project and you will see that all refinement steps are completed, ending with a review and finalize screen. Once you accept and finalize, the project is ready for epic generation. If you click Next without completing all refinement steps, the system will ask you to finish them first. When you reach epic generation, you can again choose which model to use. For deep research and complex refinement, you might choose a higher-end model like Anthropic, OpenRouter, or DeepSeek. If you do not need heavy research, you can stay with a cheaper model such as GPT-4 Mini from OpenAI. Select your model, optionally refine any descriptions on this screen, and then proceed to generate epics. After generation, you will see a list of epics. Initially, each epic may have minimal context, a short description only. To get richer content, click the Refine button on an epic. The refinement tool will generate more detailed information, such as descriptions, business value, constraints, and other fields. Before refining, you can edit the epic text to better match what you want. After refinement, you can further edit the generated content as needed. You can create as many epics as you need. The recommended flow is to start with a minimal set of epics and then expand only when necessary. For example, you might generate a small epic describing a basic counter or simple module. Refine it to get richer details, and then adjust the text based on your requirements. You can edit both before and after generation, remove any content you do not need, and keep only what is valuable. This gives you full control over the project structure. From each epic, you can generate features. Use the Generate Feature option to open the feature wizard. This will create a set of features associated with that epic. Again, the first generation may be brief, and you can refine each feature, just like epics, to add more context. The typical hierarchy is project, epics, features, user stories, scenarios, and then tasks. You can also generate tasks at each level, including project-level tasks. Use the AI Task Wizard to define tasks. There are two main types, functional and non-functional. At the project level, you may want mostly non-functional tasks, such as research, architecture exploration, or performance analysis. At the epic level, tasks may be more functional, building utilities, common classes, frameworks, or API integrations. At the feature and scenario levels, tasks may include UI implementation, service logic, and testing. You can create tasks at project, epic, feature, and scenario levels to fully capture the work breakdown. The recommended approach is iterative. Generate a small number of epics, features, and scenarios, then refine and expand gradually instead of generating a huge tree at once. This way you always understand what is being created, and you can keep your project structure intentional and manageable. Once the project structure is ready, set up your team. If you are working alone, you will be the only team member. If you have collaborators, go to the Project Team section. Every employee invited earlier through the Employee tab will appear here. Drag and drop selected employees into the project team. Assign them roles and responsibilities as needed. When the team is set up, you can start planning sprints. Create a sprint record and open its details view. Select the epic or epics you want to include in the sprint. From the selected epic, choose the features you want to deliver, using the checkboxes. Add those features to the sprint. All associated tasks from the epics, features, and scenarios will be pulled into the sprint automatically. You can also drag project-level tasks into the sprint if necessary. In the sprint view, you can see team members, capacity, workload, and an overview of assigned tasks. Now go to the sprint board. The board shows each team member and their assigned tasks. For example, one person may have 3 tasks while another has 2. You can reassign tasks, move them between statuses, and manage the sprint like a typical Agile board. Once your sprint is configured and your backlog is ready, you are prepared for code generation. Before generating code, you must associate your database schema with the project. While an LLM can guess table structures, you usually want your own schema to be used. Go to the Schema section and import your schema. You can upload a SQL file created from your database, such as a set of create table statements, or a dump file. Alternatively, you can prepare a JSON schema using the provided sample format. You can also connect directly to a database to pull the schema. After importing, you will see the list of tables associated with the project. Select your project and assign the schema to it, then click Save. This tells Projexlight to use your schema when generating code. Once the schema is linked, you are ready to start actual code generation. Open your project and go to the code generation wizard. Choose the CLA export option. Select which tool you want to use, for example, the CLA runner, and click Next. Decide whether you want to generate code for the entire sprint or for specific team members. If a single developer is responsible for the whole sprint, choose the full sprint option. If each member should generate only their assigned tasks, select the member-based option and choose the developer's name. Next, select whether you want a pure mockup or a full implementation. Choose the development type: full stack, backend only, front-end only, or QA-focused generation. Then choose your technology stack: programming language, backend framework, database, front-end framework, and testing framework. Confirm your selections and click Export. Projexlight will generate a complete export package for that sprint or developer. Download the package, called the CLA export. On your local machine, create or select an empty folder for the project. If any previous files exist there, delete them to start clean. Unzip the exported archive into this folder. After extraction, you will see a fully prepared project structure with code, configuration, scripts, and all necessary context for generation. There is no need to write prompts manually. Prompt engineering is already embedded in the package through configuration and metadata. The environment is managed with Docker Compose. To start from a clean state, use 3 basic Docker commands: Docker Compose down V to stop containers and remove volumes. Docker Compose build no cache to build images from scratch. Docker Compose up D to start the containers in the background. These commands ensure a reproducible environment. The README file inside the project contains these instructions so you can reference them easily. When Docker Compose is running, you will usually see 2 main containers, one for your database and one for the MCP server. The MCP server handles communication between the code generation pipeline and your environment. You can inspect the logs of the MCP container to see what is happening during generation and validation. Once the environment is up, you trigger code generation using a single command that the CLA tool provides. That command is also listed in the README. Run it once, and the system will start processing the tasks in sequence. After the first run completes, you can run the same command again. The tool will automatically detect which tasks have already been completed and continue from the next one. You do not need to manage prompts or manual steps. After code files are generated, you typically commit them to your repository. The project includes Git hooks that are automatically installed when the MCP server starts. These hooks enforce your coding standards and perform checks before each commit. For example, run git add to stage changes, then git commit m testing. The pre-commit hook will scan all modified files, apply your coding standards, detect duplicated code, and clean up issues where possible. Over time, a lot of generated code can turn into spaghetti if it is not governed, deep folder structures, many scripts, migrations, and temporary files. Projexlight's pipeline is designed to keep the project clean. Because all prompts, context, requirements, scripts, and tasks are centrally managed, you are not manually pasting prompts or duplicating logic in random places. Instead, every generation run is controlled and repeatable. Each CLA export bundle contains context and requirements derived from your epics, features, scenarios, and tasks. Generation plans and instructions for the LLM. Configuration for the frameworks and tools you chose. Cloud-related configuration for your chosen provider. Mappings of tasks to the relevant modules and files. With this, you simply run the provided command repeatedly until all tasks are completed. The tool tracks progress and continues where it left off. You do not need to babysit the generation or write any prompts by hand. After generation and commit, the hooks also record all created APIs. The system discovers the APIs that were generated and registers them into the API library for your project. In Projexlight, go to your project and open the API library. You will see the list of APIs that were auto-imported. Each API can be tested, documented, and used in workflows. When you push your code to the remote repository, an automated test flow is triggered. The test runner builds real workflows that chain APIs together, where the output of one API becomes the input to another. These tests run against your actual database inside the container. This gives you realistic, end-to-end validation of the generated APIs and logic, not just unit tests on isolated functions. After tests complete, you can view the test report in Projexlight. Go to the Reports section and open the latest report. You will see which APIs were tested, what scenarios ran, and whether everything passed. This reporting loop closes the generation cycle. The same single command triggers both code generation and end-to-end testing through the MCP server and your project configuration. You can then run the same generation command again to produce code for the next set of tasks or the next level of the project, such as UI layers or additional services. The command remains the same. The tool uses your backlog and task statuses to decide what to generate next. This makes the process highly repeatable and easy to operate. Once the server is running after generation, you can open the UI, create new accounts, sign in, and work with the generated application. Each new generation cycle can add features, scenarios, or services, and as long as you follow the same flow, refine requirements, configure tasks, run the export, and execute the CLA command, you keep your codebase structured and maintainable. In summary, Projexlight guides you through setting up providers, cloud, and coding standards, structuring your project into epics, features, scenarios, and tasks, planning sprints and assigning work to team members, exporting a fully wired generation bundle with one click, running a single recurring command to generate, validate, and test code. You get the speed of AI-generated software with the discipline of engineered architecture. Once everything is configured, your main job is to keep refining requirements and rerunning the same CLA command. The platform handles orchestration, context management, standards enforcement, and repeatable generation for you. Thank you.